before we get too far into this, I think I will stop for a few minutes and then we'll try to think about the context about where these standards that we're talking about will fit into our daily lives. So in your daily life as a designer, planner, trying to understand what you're meant to do, you have got a lot of regulation to deal with. There's lots of odd bits and pieces. So let's try to sort of stack this up in some sort of order about what you do. Now, this slide here is a caveat on it. This applies to what goes on today. We'll come to perhaps what happens later as we go through. So the things that you have to do, first of all, you have to follow what is legally required. So we have European regulations. Generally, they're not too many in the lighting area, so we get away with it. However, there are a lot of European directives, which are instructions from the European Union to nation states to implement law. And so a lot of UK law starts life as a European directive and UK law. And so EU regulations, UK law are what we have to follow. But the problem is law and regulations come from people who know very little about buildings. They know absolutely nothing about lighting. And so in general, it uses terms like sufficient and suitable, enough to do this, not to cause a nuisance, these sorts of words that we see, and nobody's got a clue what any of this means. And so what we tend to get is a whole series of other documents to explain what that means. So in the UK, we have a whole series of things like approved documents, approved codes of practice, even some in the planning area, a whole lot of guidance documents as well. At an EU level, what happens is the European Union talks to the European standards bodies, I'll come on to them in a minute, and says, here, we've got this bit of legislation coming through, give us some standards that helps us to use them and make sure I've got a sensible set of requirements that we can do for everybody. And so from that process, we get a set of documents called harmonised standards, most notable of which in the lighting area is EN 15193, which is all about the energy performance of buildings and how much energy lighting takes. In the UK, probably the ones that we come across here, approved documents, probably the most common one are some of the things like Part L of the building regulations. We all read the application guide and the approved documents associated with that. So we've got that lot, but we've also got things like standards, which gives us codes of practice to follow, which would be deemed to be good practice in places. And then we have a whole series of guides. So generally the pecking order of these documents is that we start with stuff up here that we must do. Now, these approved documents, you don't actually have to follow them. Now, you have to, if you choose not to follow them, you have to have a really good reason, and you have to perhaps be willing to go to a court of law to prove what you've done is deemed to follow the law, but these provide a shortcut to proving you follow the law. So I will put them as a very strong should. There's things that you should do. But as we get down to this end, then this becomes things, standards and guides become things that we may choose to use, and in general, if we do choose to use them, we're unlikely to get into too much trouble, but they're not necessarily the recipe for the best way of designing a building. Now, to make life more complicated still, or maybe simpler, a lot of this material is cross-referenced. In particular, a lot of guides are put there so that you can navigate through this maze. So if I take, for example, Lighting Guide 10 from the SLL, CIBSE, that gives you a lot of guidance on how to follow through the various daylighting requirements that you're likely to come across. if we go to the SLL code, which is a slightly more comprehensive but significantly more boring document, then you'll find that there's about 40 odd standards referenced. There's, I think, 4 or 5 major pieces of legislation and so on. So some of those guides are useful, some of them are less so, and perhaps the problem with guides is that pretty much anybody who feels like it can write one. And so if you choose to follow a guide, then see who its authors are. Perhaps if it comes from somebody like the BRE or the Society of Light and Lighting, or even the Institution of Lighting Professionals, perhaps you'll use it. Perhaps you'll be some less keen on things like the office lighting guides from various office or operation organisations, and perhaps some of the lighting guides which have got vested interests in them, like say the Lighting Industry Association. Now, all of that was nice and complicated, and then you get, well, actually, I've just been awarded a contract to do this work, and the contract says I've got to follow such and such a standard, or such and such a guide. And generally, when that turns up, it means that the person who gave you the contract doesn't know what's going on. He doesn't know enough about what he's saying, but he says, I know there's this bit of guidance out there, you shall follow it. And that's okay. It may not be the best way of doing it, but it is a way of doing it. And then finally, one problem. March the 29th of March this year, that lot disappears. Or maybe not, who knows? Who really knows what's going to happen then? Certainly the stuff that comes from regulations and UK law dependent on directives are likely to stay in the medium term. But the more difficult area is in the area of harmonised standards, because nobody knows, past this date, nobody knows what harmonised standards are going to have as a weighting. So that, and there are also other places which enumerate and elaborate European directives. So, for example, references to previous judgments in the ECJ may no longer be accessible for reference points for deciding exactly where the law is. So we may have UK law, but no case history on it, so we haven't got a clue what it actually means anymore. So 29th of March, this area becomes much more difficult. Okay, so let's start, that's the framework, which is a bit fraught, but what we have to work in. Let's move on to where standards come from. So in some ways you can start to think about most standards as guides or guidance documents that have been through a rigorous process. And by going through a rigorous process, are actually have at least some level of consensus among learned people around the industry, have come up with some good ideas and they think this might be a good way of doing things. Now there are two streams of standardisation bodies here. So if we look at these, we have here the European level, here the world level, and here UK level. And the world and European level is split into two main streams. One is electrotechnical standards and one is general standards. The electrotechnical standards tend to apply to electrical mechanical objects, so light fittings, window blinds and stuff are all would be specified in this sort of stream. You get the electrical wiring regulations coming through there. Whereas in this stream, we seem to see more general applications, how much light would be deemed to be suitable for a particular application, those sorts of things will come through here. Now, all of UK standardisation effort is focused through the British Standards Institute, and basically the British Standards Institute sends delegations of people to work at all of these other bodies when they have a particular standardisation programme going on. Now, the IEC and ISO produce standards, and those standards may or may not be adopted by BSI and published in their catalogue as they see fit. However, standards from CEN and CENELEC, they are duty bound to accept. They have no option. So if a standard comes from CEN or CENELEC, there is a procedure whereby BSI must publish that standard, they must publish it within 6 months, and they must withdraw any conflicting standards. There is also a slightly more complex route where sometimes documents from ISO and IEC are approved at a European level by CEN and CENELEC, and in that case the UK has no option but to adopt the standards as well. Also, ISO has now got a very close relationship with the CIE, and I hope you all know about the CIE. Yeah, nobody's shaking their head, so everyone knows about the CIE, that's good. So the CIE does make a number of draft standards, and now there's a fairly well established path whereby they can work through the ISO system and come out as ISO standards. And if you like, these two bodies are progressively getting closer together, and so some initiatives for standardisation start within ISO and sometimes CIE runs with them. So quite a complex network. So let's try to localise this down more to the business in hand and start looking at the BSI side of things. So BSI has goodness knows how many hundreds of committees, but the one we're interested in today is EL01, and that is the Light and Lighting Committee. It's responsible for all lighting application standards, and it oversees 3 subcommittees covering emergency lighting, road lighting, tunnel lighting. There are 21 members, about half of whom are active, and if anyone wants to volunteer through their bodies, whichever they respond, we'd love to have more people there, because generally there's a lot of standards going through. It's pretty hard work keeping up with everything, and so the more people on the panel, the better in general. So, the members are generally appointed by bodies like CIBSE, Society of Light and Lighting, the Institutional Lighting Professionals, CIE UK, BRE, the Lighting Industry Association. So anyone within a trade body or an industry body who wants to join is more than welcome. And the committee looks after 3 standards which started life purely as UK standards. There are currently 16 European standards on the books. There are 2 technical reports from Europe, and there are 8 ISO standards, or ISO CIE standards in general. So these British standards, one of those is the one we're about to, which probably is going to go, BS 8206 Part 2, which I'm sure a lot of people are reasonably familiar with. And so that's going to go to 2, and this is going to come up to 17 fairly shortly. A lot of this work here is basically lighting application standards, things like workplace lighting, lighting vocabulary, sports lighting, and so on. These cover areas, one of these covers lighting design process, and the other one covers understanding how to do lighting energy calculations. The 8 ISO CIE standards are mainly in the area of defining fundamentals. So we've got to define the V lambda function, the basic colour maths, and the basic CIE colour spaces. They're all sort of defined in those documents. The 10 other stuff from the subcommittees is mainly emergency lighting, road lighting, and tunnel lighting. So, the standardisation process is managed at a European level by CEN TC 169. They have no imagination in giving detailed data. And this is the basic Light and Lighting Committee. And that is made up of delegations from all of the European standards bodies. So in the UK, the BSI sends a delegation, forget the DIN delegation and so on. So all European standards bodies are entitled to be represented here, and generally if you go to a meeting of that you'll see about 16 or 17 bodies represented. Now, that basic committee doesn't actually do any real work. It just sits there and talks about standards and discusses how to progress. I often think of attending these meetings as an exercise in excruciating boredom. It is painful to actually listen to this because of the level. The problem is that you mustn't miss a word in any of those meetings because someone will put something silly through and you won't have noticed and it will be your fault. So these standards management committees are really hard work. The more interesting bits of work are actually done in all of these working groups. These working groups are set up mainly to manage and develop standards. And we have a whole series of them, as you can see. So we have basic terms and criteria, lighting of workplaces, emergency lighting, sports lighting, tunnel lighting, photometry, photobiology. Be a little bit careful. There are two committees working in the area of photobiology. There's Working Group 8, which is all about radiological hazard. Are you going to get various skin diseases if you work under a particular sort of light for too long? All of those issues. And then we have Working Group 13, which is much more interested in the sort of circadian entrainment, those sorts of issues. We have energy and performance of buildings. The one I suspect most people here are interested in is the Daylight Committee. Then we have road lighting. And finally, at the bottom, they have a committee to manage the energy-related products lighting mandate. And basically, that was the European Union said to Senelec, they issued what's called a mandate. In this case, it was called Mandate 485. Again, brilliant naming procedure, but some bureaucrat loves it. And basically, that just looks after minor changes to various standards and combinations of standards needed to support the Energy Related Products Directive. So some of the energy related products relating to lighting products have to come through, and we have to have a definitive way of measuring all the quantities that they want. So, as I said, Daylight is the one of interest today. So I looked on the committee website a little while ago, and it tells me they have actually 59 members from 17 nations. Now, I'm not sure, there are probably people in the room who could tell me better, but I don't think there's ever been more than about 20 people who've done real work on that committee. And real work, in some cases, just meant sitting in the corner of a meeting and nodding occasionally. And I guess probably 10 to 15 people actually drafted text and worked away at stuff. The first meeting was actually in the 7th of July 2010, so this gives you an idea of how long this process takes. We're now 8.5 years on from that, and we're just about getting the standard to hit you. And that's because getting this right was actually quite difficult. The work in earnest commenced on the 3rd of February, and so it gives you, again, you can see it takes about 6 months from initial soundings to be able to get something that we're actually going to do something concrete. So how did they set about this, and what were the considerations, and what were the areas of interest and so on? So it became fairly obvious that we had to cover daylight availability. Then sunlight was obviously an issue. View out is obviously an issue, and glare was. But the problem was that this had to work across all of Europe, and we had to be careful that we didn't conflict with any existing SEN standards. So there are a lot of SEN standards there that talk about how much light you need to do particular tasks in particular rooms and all of that. We had to stay careful of that. And there are also a SEN standard which talked about the role of daylight in saving energy in the electric lighting system. And so we had to stay reasonably clear of that. And then The other problem is that there was a lot of existing national legislation, guidance, and actually how it was done in every state that was in those first meetings was actually quite a bit different, and so that gave an extra level of complexity. And so some of the things we saw were daylight factor was used, window size, there's restrictions on buildings, allowances made for future, solar shadings, access to sunlight. So there was a lot of issues around. So particularly in terms of daylight availability, there are a lot of issues about how would you do that. So window sizing is obviously fairly easy to apply, but it's not necessarily a good way of controlling things. Obviously a window of a given size in a fully exposed site will give a lot more daylight than one that's overshadowed by an exterior building and so forth. Things to do with planning restrictions are going to be very, very difficult to implement, and so generally that was skirted around, but we noted that that was a good way of doing things. We also knew that having some sunlight was always going to be good. The problem being that as we go particularly to southern Europe, that's going to be quite problematic. If we made regulations that you've got to have 5 hours of sunlight every day, that was going to be pretty horrible. So we had to strike something of a compromise there. So focusing on the daylight bit, the considered approaches was, one, how about climate-based daylight modelling? Yeah, potentially has the ability to be a good solution. Perhaps there are some negative aspects. So perhaps it's good, maybe give an indication of performance, but it's complex to apply and experience is limited. So the population of buildings that have been designed on this at the time we were writing was relatively small. So one day it may well be a basis for a future edition of the standard, but who knows? Daylight factor is out there. It's a crude model, but hey, we've been using it for a number of years and we sort of got to live with its crudities. It breaks down in given situations, but it does have a long track record and it's easy to apply. And daylight across Europe varies, so obviously some form of weighting system for daylight availability was going to be needed. So if I just go back to here, I like to use the terminology of one of my PhD students. And he breaks down and says that this is daylight factor 1.0, what we're all used to, all love. It talks about light on working planes, it's got limitations, but hey, it's daylight factor 1.0, we can all live with it. Climate-based daylight modelling, again, is talking about light on working planes. It's sort of giving us a better way of calculating it, and the calculation takes in more potential variables. So that he would identify as daylight factor 2.0 because it's doing pretty much the same thing. And so effectively in the European standard, we've come up with a system which is effectively daylight factor 1.5. We're sort of a halfway house between the two. And the concept is median daylight illuminance. So basically, there's a target daylight illuminance level that must be exceeded over a fraction of the relevant area of the space for more than half the daylit hours of the year. And there's a minimum target daylight illuminance that has to be exceeded over the entire relevant area for at least half of the year. Now, this is a little bit now relaxed, and the wording actually says 95% now, because it's always going to be, whenever you do this, you're going to find there's some corner in the room that you can't quite achieve that with. And actually, it then became that if you use roof lights, you actually have to do this level over the whole space for the whole year, for the half the year. Okay, so minimum daylight illuminance is a really nice way in, because you can do it in two ways, and it actually allows us to start to blend climate-based daylight modelling with daylight factor work. So what we could do is we could evaluate the daylight factor over a number of points in the room, and then multiply that by the median external illuminance, and that would give us the median daylight illuminance at each of those points throughout the year. Or we could sort of turn that relationship round and say, actually, I know what the median external illuminance for this point is, therefore I can predict what daylight factor I need to achieve that. And so that's one way in. Or the other way is I could do the same thing by climate-based daylight modelling, calculate it out for whatever 4,000 odd intervals during the course of the year, multiply and then find the median result for the illuminance at each point, and check that more than 50% of my points meet the requirement. So it's a dual way into it. Hopefully it allows us to sort of move forward from where we are a little bit. And when we say points, we have to evaluate points, and the number of points is forced on us, and basically the distance between points is given by this formula, where this is the overall dimension of the room. So if the room was 10 metres long, then we'd have to have 0.2 times 10 to the 1. That would give us 10 points along a 10 metre room. So in 10 metres, this is a nice, easier formula to evaluate. At 100 metres, it's easy to evaluate, and all points in between, it's quite difficult. But hey, we've got spreadsheets for this sort of thing.
So D is distance there, is it?
Pun?
Distance.
Pun?
D is distance, or D?
D is the dimension of the room. Yeah.
Depth.
Or width.
Or width.
Yeah, you take it the longer dimension, you calculate the spacing of points based on the longer dimension, and then you work out how many points you can get across the other dimension so that you've got an approximately square grid. So the suggested requirement for the minimum level was going to be 300 lux exceeded over 50% of the points for 50% of the time, and 100 lux for all of the points, or actually 95% of the points, 50% of the time. For roof lights, we were going to say the minimum requirement is 300 lux over all of the points for all of the time. The problem in the standard is that the definition of roof lights is really bad. And basically, if any window is slightly tilted and the bottom of the window is above the working plane, then it's a roof light, which is totally bonkers. So if I have a 5-degree tilt of a window and it's 0.85 of a metre above the floor to the sill, then that's a roof light. I don't know why that got into the standard, but it's there. Perfection is never possible. You're looking...
I thought it was when all of it is over the projected area of the entire aperture is over the
But it
work
is,
plane.
if it's tilting in...
Yeah, but no, but all of it, not just a little bit of it. When
If the window's over, it says over the work plane. The work plane is a plane filling the entire room at 0.85 above the floor. Yeah, if the work plane is 0.85 above the floor, the window sill is 0.86, then the whole window is over the work plane.
no, it shouldn't be.
The work plane fills the room.
Yeah.
Yeah, so the window must be if it's tilting in. Yeah? So that's what the definition in the standard is. So we have to either live with it or do something sensible. Okay? Other elements that got into the standard were that for minimum sunlight, we would expect 1.5 hours of sunlight at 21st of March. And then view is sort of graded on its quality based on the fraction of the useful area that can see elements of view. So in this room, standing where I am, I can't quite, oh yes, I can just see the sky over there, so I've got one level of view of the sky, and I can see the landscape buildings, but I can't quite see the, oh yes, over that window I can just see the ground, so I've got 3 layers of view here, and so that counts as being quite good. Minimum distance to the outside, between the outside, so obviously if there was a wall built, say 6 metres from that window, my view would be rubbish. As it is, I've probably got, what, 50, 60 metres to the far side, so that's going to score reasonably well.
Sorry, even if it's the same building, it
Pardon?
applies? Even if it's the same building, does it apply?
Sorry?
The outside is tiles.
Yeah?
Even the obstruction is the same building, maybe we are able to see the roof from the window. Then
Like
this
the
is
LCA
considered.
building was
So, but it's what I can see from inside the room, not. So if I've got the same building blocking my view, that's not a good view. Yeah. So if this building went round the corner and this was a U shape in that building, and I couldn't, so if I was looking out, for example, into a courtyard of this building and I couldn't see more than 20 metres, that's not a particularly good view. If it was an enormous building that was 100 metres and the courtyard was 100 metres square, that would be fine. So it's all about distance of view. Okay, and minimum dimensions of window and angle, sight angle of the window. So the bigger the angle of the window subtends at my eye, then generally the better the quality of view. Now, glare is assessed in 2 ways. First of all, you can do it because if you have particular sorts of blinds or particular sorts of control, that's fine. And so various sorts of control can be graded, and that gives you a really easy tick box situation where you can say, I've got a good glare control. However, if you haven't, then you can assess it using the daylight glare probability formula. And for those who didn't know, that's the formula at the bottom. It's a really nice formula, and it shares a really good property with all glare formulas that you've ever seen, and that is it's wrong. It's a definition that all glare formulae are wrong. It's probably a reasonable way to stop the worst excesses of glare, but for a given situation, these formulae are good in the conditions that they were originally assessed, but if you try to take it beyond that, it's unlikely to be too predictive. But it will stop the worst excesses and the worst of your problems. But don't expect it to be bulletproof. So, what happens now? So we finally got this document. It was published by CEN in December. And so now we have the situation where BSI must publish a standard by May 2019. We have no choice in that. However, BSI has the option of putting a national annex in, and hopefully this will feed into the next presentation by Paul, who's going to talk about this in a bit more detail. So, at that point, I ask you, was all of that clear, or have you got questions? Yeah.
Yes, I just refer back to the distance of view.
The what?
The distance of view.
Yeah.
The distance of your building outside.
Yeah.
To what extent are you testing that? In other words, if half your view is 5 metres, but the rest of it goes out to the 50.
Well, one of the ways you could probably do that is by assessing the relative angle of that view and say, does that then comply with the, so if your angle is so if I could just see a tiny little bit of something that was 30 metres away or 50 metres away, but it was only 2 degrees wide, I would have said that's a fairly poor view.
I'd agree with that, but you don't do it in the wet finger approach, unfortunately.
Well,
I was wondering if there was a percentage, like if the majority do have 50%.
I'm trying to remember the exact wording, and I can't tell you off the top of my head. There may be other people in the room who've got a draft to hand, but
In the draft, it doesn't actually give you a percentage.
I don't think there is. So I think common sense, but in general, if you could see a tiny bit, that's not really going to count. It's a substantial volume of view that matters.
So if we said over 50%.
I don't know. But this is This is the first time the standard's been written this way. I guess we're going to find out over the next 3 to 5 years where the flaws are in it, and then there'll be a revision. Okay.
Peter.
Yeah. In the PR of the EN 17037
Yeah.
that we've been able to see online on several presentations already,
Yes.
there have been some mentions to the way to define the daily hours for daylight autonomy when we consider half of the daily hours of the year.
Yes.
Could you bring some precision on that and as well?
Okay, so basically the daily hours is notionally half the hours for which daylight is available. Yeah, which is, I'm trying to do the sums in my head, something like 2,100 and... yeah, something like that.
Okay. And also, with regards to glare, it needs to be assessed with DGP, but then over the course of a year, is there a percentage of the time that the glare should be below the...
Yes, I think there is some statements in that section, but I remember reading it, but I couldn't tell you what the percentage was.
5%. 5%.
Yeah, 5% above, okay. But it was that, yeah. Okay? More questions? Because I think we're going to have a session to come back to talk about this again, yeah?
Just a quick one. Is there a sample document that demonstrates how you prove compliance? No. Like a sample project?
No, there isn't, not as such. It's a non-supported. I would expect that there will be within 6 months of publication, I would expect a number of guidance documents to exist. Yeah, particularly from organisations like CIBSE and the BRE, I would expect that some of their guidance documents will be reviewed to align with it. And I would be very surprised if they're not thinking about that already. Maybe we'll find out, because Paul might be able to enlighten us on some of that. Okay, more questions? No? Okay.
One of the things Peter mentioned is that the UK has the option to include a British national annex to EN 17037, and that has to be drafted quite soon, in fact by Tuesday. But we haven't yet finally decided what should go in there, and part of the reason for today's meeting is to get your feedback, and we're going to be talking mostly about the issue of daylight provision in dwellings, because the British Standard on Daylight, BS 8206 Part 2, has recommendations for minimum standards of daylight provision in dwellings, which are quite low values. They're relatively easy to achieve, and they're often used in the planning process. So we're going to talk about that. We're going to talk about the issue of potential overheating and conflict with the building regulations, Part L. We're talking very briefly about daylight provision in schools. And finally, one of the things we thought it'd be nice to put in the National Annex would be specific daylight data for UK locations. But we've hit a snag, so I'm going to talk about that very briefly as well. So let's talk first about daylight provision in dwellings. And BS 8206 Part 2, which is the current standard, recommends using a thing called average daylight factor, which is basically, it's the average light level over the whole of a space. So you take a whole series of points within a space and take the average illuminance, and then you divide that by the unobstructed illuminance outside on the roof under overcast sky conditions. And the British Standard gives a range for that. It gives 5% average daylight factor as being a well daylit space, 2 to 5% as being a space with daylit character, though some supplementary electric lighting may be needed. And then it has these minimum values for housing of 2% for kitchens, 1.5% for living rooms, and 1% for bedrooms. And in calculations, particularly in places like London where there's a lot of obstructions and it's quite difficult to achieve very good daylight in a lot of places, then people have tended to rely on these last recommendations. And typically what might happen is if the planning authority is concerned about lack of daylight in a proposed building, then daylight consultants might go and calculate all these average daylight factors, and then if they're above these minimum values, then they can generally conclude that the daylight is going to be adequate in the house, in the dwellings. It might not be great, but it's going to be adequate, and that's usually enough to satisfy the planners. The other thing about average daylight factor is it's usually calculated using a simple formula, which is also in the British Standard. So it's relatively easy to calculate, and it can also be used in reverse. So if you have an average daylight factor that you need to reach, it's often quite easy to tell what window area you need, or how else you can change the parameters in order to meet that value. Now, EN 17037, as Peter was explaining, uses quite a different approach, and it has, as he was explaining, it has two different approaches. One is to use the daylight illuminance over the whole year, and what you do is you calculate the daylight illuminance on a grid of points in the space for each hour of the year, and then you take the median of those daylight illuminances, which is, if you listed them all, it would come in the middle of the list. So it's sort of somewhere in the middle of the room, or near the middle of the room. And then you say, how much of the year is a median illuminance of 300 lux exceeded? And if it's exceeded over 50% of the time, then that meets the minimum recommendation in EN 17037. As Peter said, there's another recommendation for 100 lux at the back of the room, exceeded over 95% of the space, again for 50% of daylight hours, which, as Peter was saying, is 2,190 hours of the year. And then there are also, in EN 17037, there's also higher recommendations. There's a medium recommendation, which has 500 lux median illuminance, and the minimum illuminance has suddenly gone up to 300 lux, and that's for 50% of daylight hours as before. And then there's a high recommendation for lots of daylight, 750 lux median and 500 lux minimum. Again, exceeded for 50% of daylight hours. So those are the values. And this is a sort of climate-based daylight modelling approach, because it's essentially this value, this 300 lux, it's like a daylight autonomy, or I suppose the 50% is a daylight autonomy. You've got a particular illuminance that's exceeded for a particular fraction of the year. Now there's also a simpler approach in EN 17037, which is, as an alternative to use the daylight illuminance, you can use the median daylight factor and the minimum daylight factor. And most of the daylight factors, again, sort of around the middle of the space. It's not quite the middle, but somewhere near the middle. And then the minimum daylight factor at the back of the space. And here the recommendations vary with location, because, of course, in different places you'll get different levels of daylight outside and hence inside. And the values I'm going to show you below are the recommendations for London. So the minimum recommendation is for a median daylight factor of 2.1%. That's over 50% of the space, and a minimum daylight factor of 0.7%. And there's also...
Can I ask you a quick question?
Yeah.
Is these values being selected, are they mapped onto the existing average daylight factor measurement so that they are effectively equivalent to what people are achieving today? Or do they represent a change in target?
You'll have to wait to the next slide to find that out. Okay, so there's also a median recommendation, which is for 3.5% median daylight factor and 2.1% minimum. And then there's a high recommendation, which is for 5.3% median daylight factor and 3.5% minimum. And this is a simpler calculation because you don't have to do all this simulation over a whole year. But it's I guess more complicated than calculating average daylight factors using the formula, because you have to calculate the daylight factor on your whole grid of points over the whole space, and then you have to select the median and the minimum out of those points. So how does this compare with the values we have now? Well, one of the things is that the average daylight factor in a space is not the same as the median daylight factor. And for most side-lit spaces, the average daylight factor is actually higher, typically around 1.5 times higher. It depends on all sorts of things, but it's about 1.5 times is a rough rule of thumb. And so our minimum recommendation of 2.1% median daylight factor, that actually corresponds roughly to 3.2% average daylight factor. The median recommendation of 3.5% median daylight factor corresponds roughly to 5.3% average daylight factor. And the high recommendation of 5.3% median daylight factor, that corresponds roughly to 8% average daylight factor. So even the minimum recommendation, which is about roughly 3% average daylight factor, that still may be very difficult to achieve in dwellings in urban areas, where you might be struggling to get the lower values of 2%, 1.5% in living rooms and bedrooms. So in answer to Stephen's question, these values are typically higher. Yeah. So we've been thinking about this and what to do in the National Annex, and I'm going to explain the 3 different options that we've been looking at. And what I'm going to do is we're going to have a non-binding referendum about it, and I'm going to ask you for your to vote on these. So pay attention. Yeah, we all know the trouble that non-binding referendums can give us, but let's have a go anyway. So the options that we've been thinking about, and I'll go through. I think I'll actually skip this slide and go straight on to the options, because I actually took too long this morning. So option 1 that we are thinking about is to use the minimum values of average daylight factor in BS 8206 Part 2 as an alternative method. So just to take those minimum values in BS 8206 Part 2 and just to put that into the National Annex, and as an alternative way that you could do it in dwellings in urban areas. And we had some text which was on the last slide, which was to list cases where you might have dwellings that were unusually obstructed and you'd want to use this sort of approach. And the advantages of doing that, it's a tried and trusted method, because obviously we've been doing it for years. It's easier to calculate, especially if there's lots of rooms that you have to do, or the rooms are odd shaped, or say if you're somebody who doesn't have daylight software, but you just want to check a few calculations, say like if you're a planner, for example. The disadvantage is there is a disconnect with the main text of EN 17037, which uses median daylight factor and median illuminance, and so we'd have to explain what average daylight factor meant and how to calculate it. And some people argue as well that average daylight factor correlates less with impressions of the space than median daylight factor. And I know John over here has argued that in the past.
It seemed to have been right there at the beginning with Waldron's data. There seems to be a lot of evidence that he actually misrepresented his data, and people respond to absolute values and not relative ones.
Right.
And that was right from the get-go.
Okay. So anyway, that's option 1. And then we have option 2, which for the national annex, which would be to adapt the method in EN 17037 by using lower illuminances for dwellings, which would result in lower recommended median daylight factors. Now, the standard method is based on 300 lux, but one of the things about 300 lux, it's just a standard value for all buildings, and in dwellings in the UK, or in residential buildings in the UK, generally the illuminance recommendations are lower. And so the SLL handbook, for example, it recommends 200 lux in kitchens and 100 lux in bedrooms. And in living rooms, it recommends 100 lux, but it also says you can have supplementary reading light. So we've said that's sort of like 150 lux. And then if you use those lower illuminances in the calculation, you then get lower median daylight factors of 1.4% in kitchens, 1.1% in living rooms, and 0.7% in bedrooms. This is for, again, the London data. And then if we multiply those by 1.5 to get an approximation of average daylight factor, that gives us 2.1% in kitchens, 1.65% in living rooms, and 1.05% in bedrooms, which is very close to the 2, 1.5 and 1% that we have currently in the BS 8206 Part 2. So the advantages of doing this, it ties in with the EN 17037 method, so we don't have to explain any other parameters, and also there's a rationale for it based on UK recommendations for illuminance. The disadvantage is that it does require a more intensive and time-consuming calculation, because you've got to calculate point daylight factors on this grid of points throughout the room, rather than just using a formula. So that's option 2.
Sorry, can I just ask, is there any option for clarity between houses and apartments, or flats, units that have a kind of kitchen living space, and the kitchen tends to be at the back of the space, so achieving 2% is impossible or not? Is there any kind of concept there to be able to include something like that in the annex for clarity on that?
Yeah, in the British, in BS 8206 Part 2, it says that where you've got a space that's a kitchen and a living room, then you just have to achieve 2% average over the whole space.
Yeah. And that's, but I mean, in most cases, in those scenarios, kind of majority of your space, 90% of your space is a living space, and it's nearly kind of a kitchenette at the back. And is it right in that case to go with the higher 2% for the whole space in that scenario, do you feel, or?
Well, that's a lot of local authorities, just viewing it from a planning point of view, a lot of local authorities treat such kitchenettes or treat separate small kitchens as a non-habitable space. And in that case, you would have, you could just say, well, the important thing is to get daylight in the living area. Yeah. One of the disadvantages, or well, maybe it's a disadvantage, maybe it's an advantage of average daylight factor, is it's an average over the whole space, so you have to take the whole space. With median daylight factor, you could actually just take part of the space. So you could just say, right, we're just going to have a non-daylit kitchen area, we're just going to be worried about, we're just going to have our grid of points over the living area. So that gives you more flexibility, but also flexibility can also mean cheating. So what people do is they say, oh gosh, this doesn't meet. I know what, we'll move the grid. Yeah. And so there's advantages and disadvantages.
Yeah, 'cause if there was going to be an annex, it would be great to have some sort of guidance or clarity around that issue, because it's such a, as you say, it's a flexibility. That line moves.
Yeah. Okay.
Thank you.
Yeah, and the third option is really, option 3 is really to have both. So you can either have a lower median daylight illuminance, so you could have in a living room, say, 150 lux exceeded 50% of the time over 50% of a working plane. So that would be like option 2. But also an alternative, you could just calculate the average daylight factor and say it was above 1.5%. So basically it's both options, it's option 3. Advantage is maximum flexibility of a calculation, so you could choose depending on what software you had. The disadvantage is it's more complicated. You still have to explain average daylight factor, and then you have to explain why it's not the same as median daylight factor. So you've got more complicated guidance, which sometimes people might misunderstand, or sometimes people might, Perry Chaffort, deliberately misunderstand and perhaps use the 1.05% for average daylight factor instead of median daylight factor to make it easier to comply. So, yeah, so that's option 3. So in a moment, I'm going to give you a chance to vote on options 1, 2 and 3. But I thought it would be now a good time to actually have some of our discussion and to talk about or questions about the different, if you've got questions or a point you'd like to make, Jens.
I'm still missing option 4 actually.
What was option 4?
That is actually adapting the European standard without making any adjustment to the, so it's plain simple.
So you have 300 lux in dwellings.
Yeah. That could, I would suggest at least have the option 4 on the table.
I second that.
Can I add something? Okay, as it exists at the moment, it's the methodology of the median part which is normative. That's the bit which needs to be adopted. Everything else is the recommendation part. So, personally, I think it makes more sense to just have a national annex, if you're going to have one, based on the recommended values and say, yeah, okay, that is setting the bar high, which is aspirational, but we're not necessarily going to get it in urban centres. So let's keep with the normative bit, which is the methodology and the median part, and just adjust our target values to more realistic and indeed honest ones, because that's closer to what you're likely to get.
So that's option 2, basically.
Yes.
Yeah.
Better aspirational desire to have more daylight in our dwellings.
I mean, one of the things we've been, we had one of the UK's top daylight consultants from Waterslade Consulting and Point 2, and he's actually done a whole series of studies in London of dwellings in London, existing dwellings that have got planning permission. And usually what they do for these, or what they had done for these, was to compare them with BS 8206 Part 2. And these are new flats in quite dense urban areas in London. And he found that typically you'd be looking at 80 to 90% compliance rate with the British standard. And then he redid it using the European standard, and he was finding around sort of 30-40%, something like that.
Doesn't that just make me have to design better?
I think it does mean, yeah, it does mean we have to design better, but also within the UK as well, the National Planning Policy Framework is saying that you should be flexible with applying daylight standards with the aim of getting higher density development with possibly worse daylight. And so we're sort of caught between two conflicting pressures here.
I have to say, I'd like to challenge that last comment, because I think there is the assumption that more is better. Well, I actually, coming from an architectural background, think that less is more, and that actually there is a general sweet spot for daylighting, but more. I mean, and I challenge. I mean, I find the 300 lux over 50% of the area, 50% of the time, is here is presented as the sort of a minimum target. Well, I think that's a pretty high target, and it's certainly not one that you'd achieve in any urban location, and actually does conflict with the energy and the overheat, both energy use and overheating issues to do with daylight. And I think there's a whole legacy of design guides created 30 years ago that wants us to make Milton Keynes style housing and this because of solar, because of good solar access. Well, there are a nonsense and thankfully been completely ignored because actually dense urban housing is the most efficient in carbon terms. And we should live with that because we do have to balance daylight with energy and with transport because denser conurbations are really very efficient in terms of transport.
Sorry, gentlemen.
I wondered how the first speaker said something about different having to take this standard, having to take into account different European countries' conditions. I don't know. I didn't quite get how that fitted in. Is the 300 lux something which is intended to be applied, in Greece, the same as it would be in?
I think the idea is it would be applied in both Greece and Finland, but obviously in Greece you'd need smaller windows to get your 300 lux than you would in Finland.
Can I just maybe say where the 300 came from? And it really was the best published data that we could find on people's perceptions of what is a well-lit space. And all the stuff that's been done in the past 10 or 15 years, it's been the 300 lux value is the thing that's come out and around sort of half the area and so forth. So that was the best data we could find. And when those studies compared 300 lux against average daylight factors for the space, again, they found that the absolute values correlated better with people's perceptions than the average daylight factor did.
But that was in offices, wasn't it, John?
It was a variety of spaces actually, some of the large open plan and so forth. But yes,
well, I've carried out studies with students sitting in a lecture, and they can jolly well read and write their lecture notes at 20 lux, and actually they don't even notice the difference until you're getting up to 300 lux. I mean, I do think it's very much a function of what sort of space you're in.
About judging the whole world by the visual acuity abilities of students. And a lot of if I may just make one interjection, I think we need to be cautious now, is that we're looking at measuring light in photopic lux. And the movement today now to looking at a wider spectrum in how we look at light, how we measure it and represent it, is becoming increasingly complicated by the fact that we need to account for blue-rich light. And if we're going to be talking about circadian lighting and dynamic lighting and lighting for health and well-being, obviously we're using daylight as a reference point, but we're actually using a rather simplistic way of measuring it. And I think we need to take into account that's going to be taking us on into the next generation. How are we going to be looking at light levels in buildings? And in a sense, much of this is history, really, because many of you sitting here who are not looking at dwellings but are looking at workplaces are already starting to think about the distribution of light with other measurements and how you're going to represent the performance of those buildings in more than just photopic lux. So I think we need to be a little bit cautious about it.
I'll put your name down for the next 8 years on the panel. You can do it instead of me.
Okay, well let's go on to over, and we will have option 4. So we'll have option 4, which is really not to have anything about this in the National Annex and just to go for 300 lux. Okay, so option 1. Who favours option 1, which is just to basically using the existing method with average daylight factor in BS 8206 part 2? 1, 2, 2. Peter's you're writing them down, aren't you? 2. Option 2, adapting the EN 17037 method by using lower illuminances for dwellings, resulting in lower recommended median daylight factors. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Sorry, did you have your hand up? 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, but he voted this morning 40, 46, 47, 48.
Would that be in all cases, or just would that be just be a blanket for dwellings, regardless of where they're located, whether they're urban?
No, we have got a statement in there, which actually I glossed over, so maybe I ought to. It says, in the opinion of the UK committee, it may not be possible for users of BSEN 17037 2018 to meet its requirements for some buildings, particularly dwellings. The UK committee believes that this could be the case for dwellings with basement rooms or those with significant external obstructions, for example, dwellings situated in a dense urban area or with tall trees outside, or for existing buildings being refurbished or converted into dwellings. This national annex therefore provides the UK's committee's guidance on minimum levels of adequate daylight in all UK dwellings, including guidance from BS 8206 Part 2, 2008. So that's the draft at the moment. So yeah, we still haven't done option 3 yet, which was option 3 was combination of the two, so you can have both average daylight factor and the EN 17037 method. So if I was in favour of option 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. And finally option 4, which is not to do any of these things and have 300 lux as our basis. So 1, 2, 3, 4, 5, 6, 7. Okay, thank you. So yeah, 7 I think. Yeah. Okay, thank you very much.
You want an aggregate result?
Yeah, all right, yeah.
Okay. So the aggregate result is...
This is including this people who came this morning.
Option 1, 8 votes. Option 2, trying to do the arithmetic, 70 votes. Option 3, 12 votes. Option 4, 7 votes.
Okay, thank you.
There was no option 4 in the morning session, was there?
Yeah, but yeah, we didn't do option 4 this morning.
Nobody suggested words. We're not going to go back to
Okay, I'm just going to run because I'm conscious I've taken a lot of time, so I'm just going to run very quickly through the last 3 issues, which things we might put in the national annex. One of the things, one of the potential issues which was mentioned just now is the recommendations in EN 17037 can, particularly the medium and high levels, can give in quite large window areas and the possibility of overheating. And there's a potential conflict here with the building regulations in the UK. So particularly the median and high recommendation, so the high recommendation, that typically gives you 8% average daylight factor, which in BS 8206 Part 2 we'd sort of flag up as being the sort of average daylight factor where you might have to be concerned about overheating. And so we've done this draft text, which is very high values of daylight illuminance, or, well, it says average daylight factor, but if we didn't have average daylight factor, we'd probably change that. In a room may indicate that the room is likely to be at risk of summertime overheating. This is particularly likely with single aspect flats in which cross ventilation is not possible. Requirements for the control of overheating are given in the relevant sections of the building regulations in England and Wales and in Northern Ireland, or building standards in Scotland. So just really flagging it as an issue in order to notify people that there could be this conflict with the building regulations. The other issue is in schools. Who works on schools here? Anybody work on schools? You will know that in schools there's a ESFA recommendation, a daylight autonomy recommendation, which is for 300 lux exceeded over 50% of the space for 8:30 to 4 p.m. school day. And that looks, on the face of it, really similar to the EN 17037 recommendation, except that the EN 17037 recommendation is for 50% of daylight hours, so it includes times like at sort of 6 o'clock in the morning and 6 o'clock in the evening. And although the two recommendations look similar, the ESFA recommendation is easier to achieve. So 300 lux over 50% of a school day corresponds approximately to 225 lux over 50% of daylight hours. And so the proposal is for the National Annex to recommend an 8:30 to 4 o'clock day as an alternative time frame for school buildings. So again, we're using the same methodology, but we're using an alternative time frame.
The ESA, like literally right now, are like ESFA, are literally looking into revisions of their standard.
Oh, right.
So perhaps this is a good time to feed into that.
Yeah, okay.
Literally, they were having the discussion a week ago. Last
Okay.
Thursday.
Right, thank you. Right, so that's... and the final thing that we wanted to put into the National Annex was data for different places in the UK. At the moment, the EN 17037, it just has values for London, and it gives this median external diffuse illuminance, and that's then used to derive the these recommended daylight factor values. And then what happened, Peter Rainham knows more about this than I do, because he actually used Energy Plus to generate similar values for other locations in the UK, depending, just derived from the radiation values in the Energy Plus files. And he found something quite unusual, which is that the values for London are quite a lot lower than, in particular, the values for Birmingham, which seems counterintuitive. In Energy Plus, you've got about 15% more daylight in Birmingham than you have in London. And we're trying to think of a physical explanation for that. The odd thing is, it's not just the diffuse illuminance, which doesn't include sunlight, but if you look at the global illuminance, which does include sunlight, that's actually quite a lot higher as well. And I'm guessing that may be because the Energy Plus data sets are not, they're not actually selected for radiation or daylight level. They're mainly selected for temperature. So that's a possibility. That's why we get higher values for Birmingham than we do for London. You can see the values for other places. Aberdeen, you've got the same daylight as London. That seems not right to me. So anyway, that's something that we need to look at a bit more, and I think it's...
It doesn't agree with the Hunt data, which is goes much further back than it was.
No, it doesn't. I think that's something we need to look at, and I think it's something that, obviously, if you're going to do climate-based daylight modelling, it's got to be really based on the climate, rather than perhaps just something you've got out of some computer file, and that's something that over the coming years we need to really develop and refine a bit.
I think it's got something to do with cloud cover. There are some of the Hebridean islands actually that actually have a great deal more daylight, simply because they tend not to have cloud cover from memory.
Yeah. Well, I've seen a lot of daylight data for Lerwick, which is pretty low, and so yeah, I'm not sure about that. I suppose it isn't now.
If currently we're not proposing to use climate-based modelling, what sky luminance distribution is used to get to the 300 lux? What sky is the calculation using if it's not climate-based?
Well, it is. I mean, it's based on. So what you would do is you would take these values in a computer file, and then you then make an assumption about the luminance of the sky, which in turn depends on these values. So if you've got a really high, just doing it in rough layman's terms, if you've got a really high level of light for 1 hour, then you assume it's say a clear sky, and you'd use a clear sky luminance distribution. And then if you've got a really low level of light and the diffuse is about the same as the global, then you say, oh, it's going to be cloudy, so we'll use the overcast sky. So that's so it does all, but it is all based on the values in the computer file.
Yeah. Maybe to clarify a little bit, if you do kind of see the traditional daylight calculations that you do now, you just need to see if you can reach a target higher than the recommended target for the data factor on the workday. And if you do that, then you're free to go, even if you use the CIE old Sky. That's it. So it's just a modest change to the existing methods you're using. So that's why. So, and then we find the target based on a climate factor, so to reach this. And then of course you can do the climate base, and that's another story.
Yeah. We actually found my colleague Cosmin Tigliano did some studies for different mums, and we actually found it was easier to meet the standard in the EN 17037 using the median daylight factor recommendation than using the illuminance recommendation, except in south-facing rooms.
Sorry, it's just that the EN is in fact calling for a sort of commitment to a global environmental concern, and comparing some very ambitious targets with regards to climate base, which are far more realistic than daylight factor, and discussing the standards with the old metrics, which is the daylight factor, in fact not taking into consideration orientation, which is really critical here. Isn't this counterproductive to be discussing or adapting the most ambitious standard to the easiest for the industry, rather than having a larger commitment towards trying to do our best with higher standards and climate-based, and even if it takes more time to compute, better specialists to do it, etc., just to push it a bit towards the direction that the EU is trying to take. And I find it a bit, personally, I'm a bit idealistic on the matter, but a bit frustrating to look at daylight factor still.
Okay, thanks.
Yeah, I second that point, and I think going back to the SFA, they had, I think they were quite blunt in their introduction, but they just pushed in climate-based daylight modelling, and it's like 4 years ago perhaps, something like that, and it was painful at the start, but the industry upskilled, and there needs to be sort of a catalyst, doesn't there? And I agree, sort of trying to perhaps phase out daylight factor, but it has to be led, and people have to be sort of motivated to do that.
Yeah, Emma?
Is the SAMX going to come with any software? Because I'm still trying to spread on daylight factors or architects. I don't know how to try to show them how to do this.
Yeah, I think software by Tuesday is going to be...
I think that's a good point to stop. And we're moving, thanks very much, Paul, that was really terrific, and there's some very good questions here.
So yes, I'm representing the French Association of Lighting today, and I've been asked to do a little bit of promotion. So I'm going to do this right now. I represent the daylighting group in this association that was created about 3 years ago. And our objectives are to promote, obviously, daylighting in buildings, to participate in the work of French standardization bodies, to organize an annual conference on daylighting every year, and to try and publish our work. So we're a group of 8 people coming from various backgrounds. We have teachers in schools of architecture, we have engineers, we have architects, we have manufacturers, lighting designers, and so yeah, the work I'm going to present today, we're going to present with Bernard, is based on the 2 conferences that we did. The first one in 2017 on the subject of this standard, and the one we presented a few months ago about the actual daylight performances of architectural references. So that's a mix of both that we're going to present today. When I contacted David about the work that we did, he suggested that I present the French annex of the standard, but there isn't one. There isn't a French annex, so I said, what am I going to talk about. So I've decided to explain very briefly how daylighting is taken into account in the French building regulation. So this is a very short summary of the 1,500 pages methodology. So I've tried to make it short. The first requirement in the 2012, the next one is going to be in 2020, 2012 thermal building regulation in France is about the glazing. It is required that the glazing area is greater than 1/6 of the floor area of the room, basically, or the building, the habitable areas of the building. So that's the first requirement. It's a simple one. Everybody knows it, and it's fairly easy to remember. When you look closely at the methodology, there's a second formula in the algorithm that contains daylighting information, and it's this one. So maybe there's some daylight enthusiasts in the room that might recognize something there. So let's take a closer look at this formula. So we've got the internal daylight illuminance. This is the result of this calculation. This is the luminous flux that is transmitted through the glazing. So those of you who know their photometry will know that this is the vertical illuminance on the window multiplied by the area of glazing multiplied by the transmittance of the glazing. And if we make the assumption, like an hypothesis, that we have an unobstructed site, we can say that the vertical illuminance on the window is about half the horizontal illuminance outdoor, okay? For an unobstructed site. No, if you're looking at the sea. This ratio here represents the ratio between the area, the total area of the room, all the surfaces in the room, divided by the area of the working plane in the room, okay? This is the what they call in the standard the horizontal daylit area, which is calculated like this. The daylit zone is the part of the room which is 2.5 times the height of the window minus the height of the working plane, like shown on this diagram. And this is the average room reflectance. So let's integrate all this into the formula. I'm going to be very quick. And if we consider that the daylit area is actually all of the working plane, the daylight doesn't stop where I showed you here. It doesn't stop there. So if we consider that all of the working plane is daylit, we get this. And this is actually the formula for the average daylight factor for an unobstructed site. So if you know the average daylight factor from the BRE, this is actually how the French building regulation calculate daylight in the algorithm. But it's not as simple as that. This is for the if we consider that we've got no obstruction, but if there is an obstruction, which is most of the time the case, the flux that's arriving on the window is actually a combination of direct, diffuse, and externally reflected daylight. So there's a complex formula algorithm that is done there, which I'm not going to present. But this is combined with local climatic data. So based on the part of France where you live, you don't get the same, obviously, climatic data. So the internal daily illuminance is calculated with local climatic data and all this information. And you actually get some sort of daylight autonomy based on the EN 12464, which is the standard for the illuminance recommendation for working environments. So yeah, that's how the daylight illuminance is calculated. And then based on that illuminance, this sort of autonomy, electric lighting is used. Electric lighting use is calculated, so based on the shading strategy. So if you have motorized blind and manually controlled blinds, the type of blinds, transmittance of the blinds, lighting control, zoning, etc. There's all sorts of coefficients in the algorithm that give you an energy consumption. So basically, how daylight is taken into account into the French standard is a mean to reduce the energy consumption. It's not, there's no daylighting performance required. It's just a way to reduce the electric performance, energy consumption. for electric lighting. So, like I said, this is not a daylighting design and optimization tool, it's an energy design tool. So it's actually a verification methodology. So this is for the French building regulation, but we also have something else in France. In the UK you have BREEAM, so you might know how to assess daylight in BREEAM, at least there's some credits for daylighting, I believe. In the HQE, High Environmental Quality, Haute Qualité Environnementale, this is the equivalent in France. There's a methodology for assessing daylighting, which is divided in 3 parts. The first part is assessing the daylight autonomy, the quantity of light that is given by daylight in a room. The second part of the daylight assessment is to assess the performance of the glare control strategy. And the third part of the daylighting design assessment is to assess what we would call the visual pleasantness, or like Marilyn Anderson says, the visual delight, the comfort or well-being, whatever you want to call it, the niceness that is brought by daylight. So this is assessed by the view to the outside and the daylight management strategy. I'm going to come back to this in a moment. So the quantity of light in the HQE is actually a daylight autonomy on 80% of the working plane, which is a lot. You thought that the standard we're talking about here was ambitious, but this is even harder to achieve. So you get this kind of table in the HQE. So based on the occupancy level, you get different sorts of. There's all sorts of table for the occupancy in the room, and based on the type of room and the illuminance target, you get percentages in the table of time an indoor illuminance level is exceeded during the occupancy schedule, and you get a performance class for achieving. For example, if you have like a meeting room or an office and the objective is 300 lux, and if you reach that level during 50% of the time on 80% of the working plane, which is quite hard, you get class B. Okay. So the feedback from HQE users is that it's just really difficult to assess. People don't know how to do it. People can't actually achieve the standard, the levels that are required. So this is the requirement in the HQE certification scheme that gets the most queries and questions. I mean, and it gives a lot of trouble to the HQE people. So they're really interested in the new standard because obviously it's going to make this a lot more simple, hopefully. So this is how quantity of light is assessed. Glare control can be assessed in 3 different ways. The first way to assess the performance of the glare control is to analyze the type of shading that you have, if it's horizontal blinds, vertical, fabric blinds, and visual transmittance. So based on the various performance, you get awarded points, and then you get a class of performance. You can also assess it with a DGP, daylight glare, help me, daylight glare probability, thank you, hourly assessment on a selected day. So the methodology is a bit complex. I'm not going to give details of it. You just get points, same as the other parameters. But the feedback from this assessment is that no one is doing it this way because they just don't know. And the other way you can assess glare control is if you show that you don't need any shading because either you have a north-facing window, which is of course arguable because if you have sunlight reflecting on the south facade in front of you, you might have glare anyway. But this is how it's done. On the window design and the obstruction in front of the window, if those guarantee no direct sunlight, you get awarded points. And the visual pleasantness is assessed using an assessment of the view to the outside. So they have a table like this, which if you know the standard is actually the same of the actual 1737 methodology. This is because when in 2016 HQE updated the scheme, they wanted to use the standard that we're talking about today, but it was not released yet. So they managed to get bits of it, and they got the assessment of the view to the outside, which is, like we saw earlier, an assessment of the angle of view. So the wider the view, the more points you get, the distance of the obstructions, and the different layers that you can see from your window. If you can see ground, landscape and sky, you get 4 points, etc. So you get points based on how important the view is from the room. So if you have an office, a meeting room, a bedroom, a restaurant, the view is considered very important, so the points needed are higher. And if the view is less important, like a conference room, a hallway or something like that, the requirements are a bit lower. The other parameter that assesses the visual pleasantness is daylight management. So whether you have manual control of the blinds, whether you have remote control, motorized control of the blinds, automated blinds, individual control, group control, you get various points for this and a performance. So it's a little bit arguable that daylight management is in visual pleasantness. It's a bit, for me, it's not really visual pleasantness, but it's in the standard, so we shouldn't complain. It's good that it's there somewhere. So what is the future for the HQE certification scheme assessment of daylighting? Well, they're very keen on using this 1737 EN standard in their next version of the scheme, so we'll see what happens with that next year. Thank you. And now Bernard is going to tell us about how daylight is considered in Switzerland.
Good afternoon. So there is daylighting in Switzerland. It's not every day like that, but it's sometimes very pleasant. I will present you the Swiss standard, and you will see that there is no standard dealing with daylight in Switzerland, which is quite a pity. Actually, everything is calculated through the electricity consumption for lighting. So the illuminance levels are based on the EN standard, and the calculation, the performance of the rooms or the buildings is evaluated through the equivalent number of hours where electric lighting should be at 100%. Well, a specificity of the Swiss building regulation is that for every topic there is a limit value. You should be lower if it's energy, for example. Lower than this limit. And there is a target value that you can reach if you apply the good practices. And the Minergie label, which is equivalent to HQE or BREEAM, well, is located. The target is just in between these two values, limit and target. And the requirements are analyzed for the whole building, but you have to choose typical rooms and to analyze typical rooms, and then to make an average for the whole building. So regarding lighting, so the thing is to calculate the electricity consumption, and to do that, the standard analyzes the equivalent number of hours during which electricity will be used at 100%. This includes also the standby consumption. And coming from that, the label Minergie Eco calculates an equivalent daylight autonomy, which is the hours during which, there will be no, Well, do you want me to? No, the number of hours during which you will not use electricity to light. And if you have this number of hours represent more than 50%, then you reach the label. And this is for one room. And for the whole building, you must make sure that the rooms that do not reach 50% are represent less than 20% of the building. This is quite rough, and there is no simulation to assess that. There are a list of parameters that have an influence on the light. Some of them are continuous. Some of them are step by step. For example, walls photometry. It's not a precise, a defined value for the floor, the wall, and but you have one set of dark room, which is 0.1 for the floor, 0.2 for the walls, or I don't know, and one set for medium and one set for clear rooms. That means that there are some steps in the calculations, and well, I don't want to pass to review all these parameters, but I will take an example to show you that this method is not really satisfying. Well, don't smile. So let's take a typical small individual office room with a quite bright, well, normal standard photometry for the walls and the floor and ceiling, and a good electric lighting fixture. I mean LEDs with a good luminous efficacy and so on, and a manual switch. So if I make a simulation of the daylight autonomy for that room located in Lausanne and facing south, with no shading device, I find an average, a median daylight autonomy of 35%. This is the simulation, and if I use the formula from the Swiss standard, it's an Excel sheet, and then I enter some information, and I have this kind of result. So for this configuration, it's quite close. Now, if I look at the electricity consumption, well, I have no. This is the result from the Swiss standard, 12 kilowatt hour per square meter. Now, if I just well, remove the lintel height, we see that there is a kind of discrepancy between the simulation and the formula. If I enlarge the window, it's not so far. But if I apply a fully glazed facade, then we see a very large difference between this simplified formula and the simulation. So this is a problem, well, in my opinion. Because in the formula, the total area of the window has no geometry. It's an area of glazing, and it's calculated as providing light, well, in a good way. And we know that, for example, the lower part of the glazing is not as efficient as the upper part, and so on. Now, if I put an overhang, we have also a huge difference between the results. It means that the formula is really not efficient. And I will show you another example to prove that. Look at the result here with the overhang here. And now I will add another opening here with a huge overhang also. Normally I should have more light, and that's the case with the simulation. And here the result has decreased compared to that. So, well, that's you know, we are not, well, I am not very comfortable with this Excel sheet. Maybe a last example. If I come back to the first room I've shown you, so with those results and with that 12 kilowatt hour per square meter, regarding electric lighting. Now, just compare that with this room, with a small window, with a very small window. Okay, there is no daylight autonomy in the two methods, but here the electricity consumption due to lighting is not so high, and in manual switch. And if I tick dimming and absence sensors, then I have a very low electricity consumption. So this is not credible, is it? No. We can't believe this this formula. So the conclusion is that we are quite happy if Swiss people could upload and maybe include some of the consideration of the new European standard. But we'll see further. Right now, as a Swiss professional, I would like the EN to be implemented in Switzerland. But as a daylight specialist, I have some.
Can I just ask, where does this standard originate from?
This
it looks similar to some stuff some of the DIN method from years ago.
I don't know. What I know is it has been constructed by electric industry.
Okay.
Yes, by lamp or luminaire sellers.
Can I ask, there was some test work in Lucerne in the Hochschule with a test room looking at this relationship between the thermal and energy load of electric lighting and daylighting. Were you connected with that as well, and these results?
I'm not sure I've well understood. You know, I don't speak English very well. You mean the link between energy consumption and daylighting? Actually, this link is not good at the moment.
There's a test room.
Oh yes, in Lausanne.
Yes. No, in Lucerne.
In Lucerne, yes, yes, but you know, a test room is used some days per year with some experts or students. My opinion is that it is not representative of the actual energy consumption. Oh, well, the behavior of normal people, I would say. But that's an opinion. Now I will present you the result of a parametric study we've done a few months ago with Collège de Lumière Naturelle. The idea was to check whether this new European standard is easy to achieve, or is it easy to achieve, or to have a good ranking with this new European standard in day-to-day practice. So, as it has been mentioned before, there are 4 topics, and I will only focus on daylight provision. I don't have to spend a lot of time on that, but as you know, on daylight provision, there is this criterion on median value, and the other one on minimum value. I'm not sure if it's a good approach, but we decided in our approach to make a mix between those two ranking, and to decide that the lower ranking will have the priority. If you have high ranking in for the median value and a medium ranking for the global ranking is medium. Well, that's a decision. I'm not sure it's a good decision, but it's a kind of aggregation of the two rankings. Just to remind you, the threshold values to have 100 lux on the work plane, you should have a 0.7 daylight factor value, and for 300 lux is 2.1. It's just the relationships between them. Well, it has been explained by Paul. So here is the parametric study. So once again, the test shoebox will know architecture conception. Here it's a square shoebox. I mean 5 by 5, 2.8 meter high, rather high, well, good height, and fully glazed. And this room is located at the upper floor. I mean a very low obstruction angle. The wall reflections are the reflection coefficient are very high. This is hard to achieve in day-to-day practice, but it's the best case. The opening is fitted with very clear glazing, with not a lot of frame, and the orientation is south. And the localization, London. I know it's not so important here in London to have south or north, because of the sun. I'm sorry. No, it was so beautiful today. So here we have our base case, and here is the ranking regarding median value. So my opinion is that it's quite well glazed and normally well delit. And regarding the ranking, it's not so high. It's only medium. And to have a high ranking, I should have a smaller room with always the same height. So in that case, it represents I don't know. Maybe the window to floor ratio is about 70% or 60 to 70%, which is a lot. And in the other direction, you know, for example, a room like that is not so deep and so disadvantageous, and it only reaches the minimum. I'm sorry, well, whatever. Now it's the minimum, the ranking for minimum value. You know, this minimum illuminance on 95% of the surface, and we can see that it's even more hard to reach a good ranking for this criteria. Now, if I merge the two rankings, median and minimum, you can see that. Well, you have to have a window to floor ratio, sorry, over than 55% to reach medium. Here is the window to floor ratio. To reach high, you have to be above 55, and if you are above 40, you are minimum. Now, if I just go one stair below. I can see that it's harder to have a good ranking. And if I go with a 33 degree outside obstruction angle, I can see that it's nearly impossible to have it's impossible to have high ranking, and it's hard to have even medium ranking. And some of the rooms are outside the standard. And now, if I'm on the ground floor in a city, normal city, it's not possible to reach the medium ranking, and most of the rooms are outside the standard. So I could show you a lot of examples. The thing is that my opinion is that let's have a look at that. It's always the same room, and I've only changed the glazing transmission, which, for example, the building just in front of us has probably 0.6 or 0.5 transmission factor, because most of fully glazed building have to have a selective glazing. So if it's the case, then it's even harder to reach medium or high value ranking with this standard. So another point is that you know that there are two methods: the simplified based on daylight factor and the precise method based on dynamic simulation. And the two methods do not give the same results. It depends. It's not always the same way. Here we have no shading device, so this daylight factor approach do not take into account movements of the blinds. But in that case, without shading device, then the dynamic simulation, let's enter the sun and full of daylight, and which leads to a better evaluation. But if I include the blinds, the movable shading device, then it's a little bit different. The same room is well evaluated with no shading, and also well evaluated with Venetian blinds, as far as light is not absorbed but reflected, and the light is in the room. With fabric blinds, there is a bad ranking, because when the sun is there, then the light is rejected. And with electrochromic, it's a little bit different. If I look at another orientation, well, the results are changing a little bit, but not much. So, in general, I would say that, of course, this new standard is welcome, because, for example, in Switzerland, we really need a good standard. And the fact that it includes view, sunshine, the sun, the daylight provision, and glare, it's all the subjects are in it's a good news. The problem is that it's extremely demanding, and my opinion is that we probably, if there is a new version or that adaptation, I would say that the minimum ranking is good. The medium is very good, and the high is outstanding. I don't know. Maybe the wording could change, because it's for a building owner, it's not normal to say, not for an architect, for example. It's not a good marketing to say, don't worry, you will have the minimum and it will be good. And this is a point I think it's a problem to encourage fully glazed building, especially because this standard is applied from Sweden to Cyprus, and of course the problem in Sweden with fully glazed building is heating in winter. And the problem is in Cyprus, overheating not even in summer, also in mid-season. So that's a problem. I think it should be looked at, and it's not for urban environment with outdoor masks. I think there is a problem. My opinion is that we should, if the situation is not good and the designer cannot change the situation, then you should take into account the fact that it's in Sweden and it's in urban environment and it's oriented to the north, for example. I'm not sure of that, but maybe, for urban environment, there will be a very little number of buildings that could reach even a ranking. The good news is that it eliminates deep rooms from the ranking, and also very good news from my point of view is that it eliminates building with external layers, double skin, because as soon as you put another skin in front of the real facade, then you diminish, you lower the lighting. And we all know that it's a huge tendency, this double skin facade, so it's good for. So that's all. Oh no, that's not all. Sorry, I have to make some marketing. We've made a simulation with this small tool, Dial Plus, and I just show you to mention that the simulation tools are at the moment including all the topics of this new standard, and it will make it easier to handle by the professionals, because as soon as you talk about light, but not only light in space and time, it's not so easy, and then you add the glare in time, so for each period, the sunshine contribution, and well, it's not easy, and we have to provide professionals with simple tools. So this Dial Plus tool also embeds the daylight provision calculation for both simplified and detailed methods. It includes the view out calculation, the evaluation of the horizontal angle only, and it also includes the exposure to sunlight, and it will, in the future months, include the daylight glare probability. I just show you how it works to go to the end of the marketing period. For example, this room with three windows. Here is the daylight factor analysis. Here is the daylight autonomy, diffuse daylight autonomy. So the same principle as in the standard, but including the effect of orientation. I mean, it's not the same contribution for all the facades. And here is the analysis for daylight provision. So here it's minimum for median and minimum value. Here is the evaluation for sunlight exposure. So it's based on analysis. Here on the 21st of March, we have more than 1.5 hour. And the last analysis is the horizontal side angle. So for all these points, there are three windows. They all access, most of them access to more than 54% of, 54 degrees of view angle. Here it's 28. Here it's 14, and it's below 14. So it's a way to analyze the room, and then to have an advice about that. So now that's it. That's all. Yes. Thank you.
Okay, so I'm back to present you some case studies, some analysis that we did with existing buildings. Because when we started looking at this norm last year, we wanted to see how it was performing with existing buildings, so we did some case studies. So here's a selection, 3 rooms. So the first one is an open plan office, the second one is a small meeting room, and the third one is an open plan office which is as glazed as possible. Doesn't have roof lights, but it's fairly glazed. So the assessment on the 4 standard parameters gives the following. So this is the open plan office with its characteristics and the size and everything. Different pictures of the view in the office. So when we did the analysis on the daylight provision, we noticed that the minimum level was achieved on the daylight provision. So that's that. The view to the outside I calculated using the angle of view. So the angle of view is 50 degrees from the point that's further from the window. So I chose to do it like that. So 50%, which corresponds to the medium performance level in the standard. The second parameter for the assessment of the view to the outside is the distance of the view. So in this case, we get about 90 meters between the room and the obstruction. So that's a performance high in the standard. And the view to the layers of view that you can see from the window, you can actually see 3 layers: the ground, the landscape, and the sky. So it's a high performance. But the overall performance is medium because there's 1 medium and 2 high. So medium wins in this case, which is pretty good. So the analysis on the third parameter is on direct sunlight exposure. So it's fairly simple, really. You just draw your obstruction with the software on the sun path diagram, and you look at the duration of sunlight on the selected day between the 1st of February and the 21st of March. And in this case, it's about 4.5 hours. So it's a high performance. As you could see on the image before, I mean, the obstruction was 90 meters away, so that's quite far. So you get sunlight, and it's east facing, so you get a lot of sunlight in the morning. Regarding the glare protection, in this case, we get opaque, manually controllable Venetian blinds. So in the standard, there's, like we said before, there's the detailed methodology, which involves a DGP calculation, and there's a simplified methodology, which involves a characterization of the shading system. And in this case, it's very simple. As long as the blinds are opaque and they block direct sunlight and they're controllable by the occupants, you get a high performance. So that's really easy to assess in this case. I think it's good because if you have blinds that do what they're meant to do, you get a high performance on the glare performance. So that's that's a good thing in the standard. So this is the overall performance in this room. Basically, we did this. I'm showing you this to just demystify the standard a little bit, because it can seem quite complex when you first look at it. But doing the assessment, I'm not going to say that it's simple, but it's doable. It's not impossible. You know, it's fairly accessible, I would say. So this is the second room, the meeting room, which is facing the other side. It's facing west with this characteristics here. Another view of the room. This room doesn't perform according to the standard criteria or thresholds because it's narrow, basically. You get the performance, you achieve the performance on the median value, but you don't achieve the performance in this case on the minimum value because the back of the room is too dark, basically, which is often the case with narrow rooms. So no performance here. The view, you get an angle of 38 degrees measured here. So that's a medium performance on the distance of the view, and also a medium performance because you can see the landscape and the sky from this point of view. So that's an overall medium performance on the view. On the sunlight duration, same as before, I drew the obstructions facing the building, and you look at the march, this one here, so you get 1 hour, 2 hours, 3 hours, about 3.5 hours, maybe 4. I mean, that was done a bit quickly, but that's a medium performance. Same shading control strategy in this one. Manually controllable, opaque Venetian blinds, performance high. So this is the summary of performance. So in this room, this is the third one we tested. There's a mistake, bad copy and paste, sorry, in here. The depth of the office is actually 6 meters, and the width of the room is 13. The depth of the room is 6 meters, sorry, and the width here is about 13 meters. So that's a mistake here. It's quite a large building, very glazed. The daylight measurements show that it's a very well daylit room. This is done on a clear sky, no sunlight in the room, but you get fairly high levels of performance on these daylit conditions. The assessment, the calculation of the daylight factor distribution in the room gives a medium performance. We could consider that it's high. It's only medium because the median is 8.1, which is actually the highest level in the standard. But the minimum is just because of this little darkish corner. So maybe we could just move the grid a little bit and we could get a high performance because I think it deserves a high performance, this building. I mean,
in reality, there is no partition on the left.
Yeah, so there's light coming from the left as well. That's an overall performance of medium. The view, same methodology. I placed a point at the the points that gets the least view in the room, so the further away from all the windows. And I looked at all the obstructions facing this point. So the angle of view is 120 degrees, and the distance of the view, I measured the distance of each of the buildings and the height, and I did some sort of weighted average to get this average distance of the view. So this is a high distance of view. And you can see the 3 layers of the view, so this is high as well, and an overall performance of an excellent view to the outside, according to the standard. Same methodology with the direct sunlight exposure, so your sun path diagram, and we get a high performance in this case. The 3 levels, just to remind you, are 1.5 hours to get the minimum performance, 3 hours to get the medium, and 4 hours to get the high performance of direct sunlight. Now, the glare protection in this one is interesting because this window is facing north and there's no blinds. So it's always very arguable, like I said before, like you know, it's not because it's north that you're not going to get any glare. You can get glare from the refraction opposite in the buildings opposite the window, or even if you get if you can see the sky, if it's very white, it can be glaring. So no blinds on the north facade, not good. And on the east facade here, there's external Venetian blinds that are controlled with automatically controlled with a sensor, an irradiance sensor that closes the blinds when it exceeds a value. I believe it's 200 watts per square meter, something like that. So if you get direct sunlight, blinds down. But there is no individual manual control possible, so the standard doesn't like that, and I don't like that either. No performance on the glare according to the standard because the blinds can't be manually controlled by the people in the room. So this is the overall performance. The 3 rooms, the performance of the 3 rooms. And also, we did some more analysis on other types of buildings, especially on the daylight provision criteria. So we went and did some measurements in various types of room and measured daylight factors in these rooms. And also, another thing that I'm quite interested in, because I teach to student architects, is that when I tell them about 2% daylight factor, 3% doesn't mean anything to them. So I try to show images of those values in order to get some sort of correlation between the metric and what it's actually going to give as, you know, a sensation, a visual sensation. So this is another thing we did in the last conference that we had with our daylighting group. And sorry? Are they the median daylight factors? I can't hear you. Are they the median? No, they're the average daylight factors, these. Yeah, sorry. But these are we simulated these rooms, and the performance that you see here is the results of the simulations. And I also borrowed a student's scale models. He had a model with, he was showing different types of building facade, and I thought, oh, that would be interesting to get some measurements in that, and actually take some pictures and see if we can correlate the metrics with the visuals. So I did some measurements in these. I didn't do measurements in the fully glazed facade, but and we did some simulation to compare with this. So, and we compared with the standards. So basically, the daylight factor, there's a big difference in the daylight factor here, average daylight factor, and in the models measured, and in the simulation, because in the models I only had 9 illuminance sensors, which is quite, it's not a lot because it's a lot to the scale of the model, but it's actually quite a big room when you think of it. So the daylight factor assessment in the simulation, I think, is more accurate than the actual measurements. This is the window to wall ratio. This is the window to floor ratio. When in red, it means that it doesn't pass the French regulation 1/6 that I showed you earlier, which corresponds to 17%. To pass the building regulation in France, you need to have 17% of glazing window to floor ratio.
Yeah, Yannick, have you got the wall thickness in the simulation?
I think we did. Yeah, because they were quite thick, the walls. So we put the wall thickness in there.
Can I ask you what test conditions you tested the model under?
Sorry?
What test conditions were the model? For the
It was
CIE
sky.
Or did you do it in a...
Oh, the model. No, I did it on my balcony. Why not?
It's a waste of time.
It's a waste of time?
Yes.
Why is that?
Because your sky distribution could be anything.
Well, how could I do it?
In a sky simulator with a CIE distribution. Otherwise, it's making this comparison really, I'm sorry to be so blunt about it, doesn't mean anything.
Okay.
I mean, however,
but it was a
scale
uniform
models
sky.
tend to overestimate the amount of daylighting compared to actual materials.
Okay.
And that's been demonstrated a long time ago, but forgive me for being so blunt.
So this is a comparison, basically. I just wanted to show performance and metrics and images. And I just wanted to finish with this. This is a church that was done by Le Corbusier in France that I visited a few months ago, and I did some daylight measurements. The daylight is coming from the roof here. There's a square red opening here, a yellow one here, and there's another one there and one here. This is daylight as well. This is daylight. And this is electric lighting, but it's very minimal. I know it's very difficult to guess from a picture, but can you make a guess of how much illuminance you've got here? It's just impossible to guess on the picture, I know. There was 15 lux. And in this church, it didn't seem dark at all. I mean, because it was very uniform and there were not really any particularly dark areas, it didn't really feel like 15 lux. Yeah, you could say maybe 200 or something. If you look at this room here on the left, you probably get more than 2,000 lux. It's very bright. I mean, of course, it's very daylit. But my point is that as you know, the impression of brightness in the room is not only a question of illuminance level, but it's also a question of good uniformity and you know, a low proportion of dark areas. If you have a room that's not very well daylit but doesn't have very dark areas, overall it's not going to seem too dark. I mean, like we can see in this situation. I mean, of course, this is an iconic building, but it wouldn't pass anything in the standard, obviously. Okay, thank you.
We have some time if anyone excuse me, would like to ask questions or raise points, ask questions of any of the speakers today. This chap here was first.
Simple question. A question about the Dial Plus software. Is that free like dialects, or will that be?
It's free for education purpose.
And just actually, just another question. I mentioned earlier about the ESFA, which is like the English Skills Funding Council. They are desperate to sort of open the breadth of software able to sort of calculate their metric. Could we connect? If I give the spec, could you comment on whether it's feasible, and I'll pass it back to the ESFA. That would be very useful information for them.
Stephen?
I'm going to stand up, sorry. Just with respect to what we were invited to look at and vote on earlier today, I think we should be cognizant of the fact that the way we use buildings is changing, and we're encouraging people to treat living and working spaces in a much more flexible way. As a consequence, I would suggest that we should be considering, if not today, and I think it's very dangerous to make legislation on the hoof, though our expert legislators are doing it at the moment, is that we should consider the trajectory of the way we use these sorts of standards. And to answer Jens's challenge is that we do actually have to be a little bit aspirational about these things. And I noted about the human-centric well-being factors which are now being introduced. So I'm like Gulliver Swift, I'm going to make a modest proposal that if the United Kingdom insists on having an annex, it should have what's politely called the sunset clause. It should be dissipated within, say, 5 years, which will give us enough time for us to consider the consequences of taking up the European standards and the associated aspirations that we're now seeing in lighting, which involves an understanding of the non-visual effects. Right? And as a result, whilst we may need to make a very quick adjustment, and we need to look beyond that into the future. Thank you.
Can I answer that point?
Please do.
This, as in all other European standards, will be mandatorily put forward for review in 5 years in any case. So, by default, if it is then revisited, then the national annex will have to be reconsidered at the same time that the whole review is carried out. So, by definition, all standards have a sunset clause of 5 years of which they need to be reviewed.
Thank you. Anyone care to follow up on anything?
Reference has been made during some of the talks about town planning, and a number of us here work in and around that field. I was just wondering if we might invite Paul Littlefair just to comment about what sort of time frame the BRE might look at updating its guidelines if and when a UK annex is adopted, because that's the document that the local planning environment tends to look to and the whole planning policy refers to.
Thanks. First of all, we need to find out what's actually going to be in the standard and the national annex, and that will happen quite soon. What we are hoping to do is to get funding this coming financial year, so beginning in April, to review the BRE guidelines. If that application is successful, then we'll probably be reviewing the guidelines this year and then republishing something next year. What we'd like to do, if we do that, is to have perhaps another meeting like this, or a meeting organised by BRE, and get everybody's views on what should be in the BRE guidelines as a result of what's in the standard.
Any final points? No, in that case I'll move on to the thanks. And first of all, I'd like to thank everyone who turned up and stayed through the session. That's a really terrific turnout, and I hope you really enjoyed it and learned lots. I'd like to thank Spyros for setting up the room, and the University of Liverpool in London for providing it. And of course, most importantly, the 4 speakers, without whom we wouldn't have had a meeting. Particular thanks to Yannick and Bernard for presenting in what was not their first language. So I'd like you to join me in thanking them in the normal manner.